You know I could edit this. Alright, here we go. So, listen, we wrote. Okay, so we just said that. So far we have equation with only one solution, correct? Yeah. Now some linear equations have no solution, and some linear equations should have infinitely many solutions. Okay? This equation is called identity. Okay? So let's look at the first equation. Let's see what we get. So how many people did use the distributive property and wrote this as what?
3x plus 6.
And you say, wait a minute, that's kind of, look at the left and the right side, they look the same, right? So what did you do next? Raise your hand. How about Robert?
I brought 3x over to the...
In other words, you subtracted what from both sides?
3x.
Yeah. And tell me what you get there, Robert. 0 plus
6
equals to? Okay, and then you get 6 equals to? 6. Yeah, and I could divide both sides by 6 or subtract 6, but I still get
0.
I get 0 equals to? 0. But at this point, look at what you get. You get left side. What does 6 equal to?
6.
Does 6 equal to 6? Is this true every time? Yeah, 6 is always equal to 6. Guess what? Guess what your solution is then when you get something like this? This is when you get infinitely. And so what's your solution actually? No, the way we write the solution is we say all. So I use a little brace. The solution, because they're infinitely many. What do these infinitely many solutions look like? Yes. Virjan? Oh, okay, sorry. Let me write down the answer first. So yes, what do you think the answer is? All real numbers is correct. Oops. All real.
I can see our lesson we learned like last week playing into this one.
Really? Good.
Yeah.
Now, why do you think my solution is all real numbers? What do I mean by this? Oh, sorry. Virjan had a question. Yeah, Virjan, what's your question?
Don't you subtract the 6?
Oh, you could have subtracted 6 first. Then you would get 3x equals 3x, and then you subtract both sides by 3x, and you get 0 equals 0.
I subtracted 3x and
I'm sorry?
I subtracted 3x and
Okay, then what'd you get?
0.
Yeah, so I could actually do that too here. I could subtract 6 both sides, I get 0 equals to 0.
So
But as long as you get the left side equals to the right side. I mean, I could have actually stopped right here if I wanted to. Does that make sense?
it's still right.
And yeah, it's still right. And because, let me explain to you why. You could have actually stopped right here when you see that, oh, left side of equation looks exactly like the right side. You could stop because this is always going to give you the solution as what? Now, why? That's the important part. Because why do I get all real numbers? What? One person has their hand up. 2 people. 3. Okay. Thank you for waiting. Go ahead, Blake. Why do you think my solution is all real numbers?
Because if it's both, everything on both sides is the same. If you subtract this minus 6, then you start with 3x and 3x, and divide by 3, it's going to equal x equals x.
That's exactly. Did you hear what he said? He's explained it really well. Look at this equation right here. Oops.
Whoa.
Yeah. I didn't want to do that. Here. Look at this step. Blake is saying, well, if you get the left side equals the right side, no matter what you plug in for x, it'll always be equal on the other side. Right? So you're no matter what you plug in, right? Like if you plug in x equal to 0, 1, 2, 3, the left side will always equal to the right side. That means I could plug in any numbers on a number line. And what do we call all the numbers on the number line? Yeah, all real numbers. That's why your solution, you give me any numbers you want. For this equation, you plug in anything on the x, anything for x, left side would always equal to the right side. So that's when, but by the way, what is the equation? What's the name of this equation then? It's called identity equation, okay? But when I ask for the solution, what are you going to write?
No solution.
What?
All real numbers.
That's totally opposite. When I ask for the solution for this then, right? If you get the left side equals, you see right here, you got left side equals to the right side. You get 6 equals to 6, right? Or you could get 0 equals 0. Whenever you get that, right, your solution is all real numbers. That's what I want you to write down on your test or on your homework. Does that make sense? All right. Robert, you have a question.
Would it also occur with fractions?
Yeah, it could be fraction equal to fraction, like 2/3 equal to 2/3. If you get that, yeah. Right? Left side is always equal to right side. It could be fraction, decimal, whatever. As long as the left side is equal to right side, that means you could plug in any numbers you want for the variable. It'll always work. Because left side equals the right side, right? Does that make sense? Whenever I plug in for x on the left side, it'll be exactly right. Exactly same on the other side. Does that make sense? So again, whenever you get this kind of equation, you as your solution, you write all real numbers. That's it. Okay. May I move on to the next one? All right. Then who could tell me how to do the next one here? How about okay, Blake. I'm sorry. No, Blake. Yeah, just. How about Jake? I meant Jake. Yeah, sorry.
You do the 3x plus 6 is equal
Oh,
to
so you
3x
distribute this
Yeah, we
that 3,
distribute
so you get 3x plus what?
plus 6
equals
because you
to?
do 3 times 2.
Uh-huh.
And then you get 3x plus 4 on the
Good.
other side. And then you can do minus 3x on either side.
Good.
And then it would be 6 equals 4, which doesn't
But
make
yeah,
sense, so it's
what
no
does
solution.
6 equal to?
6.
6. It doesn't equal to 4. Guess
Yeah,
what?
so it's no solution.
This is, you're exactly right. This one, no solution. Why do you think I write no solution for this? That's the answer right here. Raise your hand. Jer. Oh, okay. Who could explain? Why do you think the answer is no solution when you get something like 6 equals to 4? Mylan.
Because 6 only equals to 6.
6 only equals to 6, yeah. So, so, yes. Say it a little bit louder. Yeah, it's impossible. No matter what you plug in for x, right, guys, it's always going to be wrong. You know what I mean? There's no way you're gonna make the left side equals to the right side.
Yes.
Does that make sense?
Are you believe?
No, it doesn't. They're calling the administrators. Yeah, they don't know where they are. Anyway, so does that make sense, guys? Yes?
Oh, so I thought.
So no matter what you plug in, look at this. Look at this equation, guys. Look. 3x plus 6, right? You get 6 equals to 4, right? So no matter what you plug in, there's nothing you could do to make the left side equal to the right side. So how many people thought that you always get a solution when you solve? I did. But is that true? No, there are some equations where you cannot solve. No matter what you plug in for x, left side would never equal to the right side. So therefore, that one has no solution. Is that okay? All right, then let's look at the third example. Elena, can you tell me how to do the third example? What should I do? Again, distribute 3. And I get what?
3x plus 6.
Good. Equals to? Good. Are we go okay so far? Then what should I do next? How about Robert?
You want to minus 4 from 6.
Oh, let's get rid of the x's first. Is that okay?
Minus 2x.
Yeah. By the way, it's not minus. Subtract 2x. Now, why don't we get? Okay, why? That's exactly right. I would subtract 2x. Why get rid of 2x instead of 3x? Could I get rid of 3x if I wanted to? Yeah, but why do you think I choose 2x instead of 3x? I don't think we actually talked about this, but this is a nice sort of tip whenever you solve. Yeah, Elena.
Because if you subtracted 3x, you have to get 1x and you get a negative.
Yeah, you get negative coefficient. Does that make sense? So whenever you have a choice where to get rid of 3x or 2x, you want to get rid of the one that's smaller. Look at the coefficient. Which one's smaller, 3 or 2? 2. So you want to get rid of that one. Then you can kind of keep that variable positive, the coefficient of the variable positive. Very good. Then when you do that, you get 6 equals to, on the right side we get, oh, I don't get 6. Oops. What's 3x minus 2x, guys?
X.
1x plus 6. Here they cancel out, I get 4. Then of course, Camry, what should I do next? Yeah, I need to subtract 6 because 6 is adding, right? So to undo adding, you subtract 6. And so, what do I get here? How about x? Okay, so how about Hasten? What do I get?
-2.
Yeah, x equals 2. -2. This time, how many solutions do we get?
1.
One solution. X equals. So see, there are three cases, right? Whenever you solve linear equations, it's possible to get one solution, as what we've been doing so far, or sometimes you get all real numbers as your solution, right? That's when you get infinitely many solutions. And then you get no solutions, right? It is possible to not get any solutions. Does that make sense, guys? All right. Are we good? So if you're done with those, why don't you then, you know what? I want you to kind of ignore this thing. Can you cross it out? So tell whether it has one solution. Actually, can you just erase everything? And I want you to just solve. And tell me the solution. Erase all this, because I don't want you to I don't want you to be confused. Oh, watch this. I could do this.
What?
Oh, that's not good. Wait, hold on. That's not good. Yeah, I know. Let me. Can you just do this?
Well, I can't do that.
No, I mean, can you just solve? That's what I mean. Can you solve these three? Tell me what the solutions are. Okay, go ahead. Solve.
That's it?
Yeah, just solve these
I
three.
feel like you erased the whole thing.
No. Okay, go ahead. Everybody try. Okay, who wants to try those three problems? First, erase those three things. Okay, Brigetta, do number one. Number two. I would like to choose Nick and Cami, come on up. Can you erase the ones on the two? Alright, let's see. Go ahead.
I've already been on YouTube.
Hey, maybe we'll do it later. Do 1, 2, 3. And then do it in the middle, kind of, because I don't think you're. Yeah. So then right? Huh? Alright, so let's see if you got it right. Maybe we'll do this more. We'll give you some other people a chance. Yeah, that's true. I'll give you one more in a minute. Okay, let's see.
You don't know.
No? Why?
So awesome.
Okay, let's take a look at these now.
Oh wait, I don't agree.
Master Nick.
Dude, you want me to write like two? What do I write? Oh,
Real numbers.
is that it? Right?
Thank you. No, we'll figure it out. Thank you. That's good. Okay, good. Hey guys, how many people listen up? Hello. Pay attention. Okay, hello. Listen, how many people got number one, -20? Raise your hand. Good. How many people got number two, all real numbers as your solution? Very good, very good. How many people got no solution for number three? Excellent, good job. Any question on these? Got it. Okay, very good. Okay, so hold on.